In this video, we're going to go over each of the properties of water and why water is important to life. So when talking about the properties of water, we need to start with the structure. The structure of water is that it is H2O, meaning 2 hydrogens and 1 oxygen, and each bond is polar covalent. The oxygen is slightly more electronegative, meaning that the electrons are going to be more pulled towards the oxygen than either of the hydrogens, and the overall molecule is bent. So if we take a look at what that looks like, you have a hydrogen, an oxygen, and another hydrogen. The electronegativity is aimed towards the oxygen, making this side more electronegative. That should be like a delta. There we go. And each of the hydrogens are more electropositive. So the electrons are hanging out over here and not as much near the hydrogens. The overall effect of this is that the molecule as a whole has a much more positive side on one end and a negative side on the other. And molecules of water will orient themselves in a way that the positives and the negatives are aligned towards each other, forming weak bonds, HOH, between each one. And these weak bonds are going to be called hydrogen bonds. And remember, this is all in a 3-dimensional structure, not a 2-dimensional structure. So this is happening in all directions, with more hydrogen bonding happening towards you, away from you, etc. So now let's take a look at the properties of agua. And there's quite a few of them, but all of them are really going to start with the fact that water has an incredibly high cohesion and adhesion, and all of this stems from the fact that it's got strong hydrogen bonding. Cohesion refers to the fact that water sticks to itself. It's very loving of itself. And adhesion means that it's going to stick to other things, such as glass or anything else that has a slightly polar surface to it. And so all of this sticking to itself and sticking to other things mean that it's really, really good at dissolving other substances. And so we say that water is the universal solvent because it can dissolve anything that is polar. Quick reminder for you, like dissolves like. What does that mean? Is that if you have a substance which is polar, it will dissolve another polar substance. Non-polar substances will be dissolved by non-polar substances. So water and oil do not mix. Water is polar, oil is not. So anything that dissolves in water must be polar. Anything that dissolves in oil must be non-polar. Also relating to the fact that we have a high cohesion and high adhesion is that water takes a lot of energy to be able to raise the temperature because the water molecules are so stuck to each other that they can absorb heat without vibrating too much and start moving away from each other. And so that high specific heat and that high heat of vaporization just refers to the fact that it's going to take a lot of heat to raise the temperature and a lot of heat for it to go from the liquid state to a gaseous state. What does that mean for living things? A lot. When we think about Earth's oceans, those are going to be regulating the temperature of the entire Earth. If it weren't for our beautiful oceans, then we would get incredibly hot in the summer and incredibly cold in the winter. And I'm just going to doodle a little picture of the Earth here to illustrate, just because I don't think we have enough pictures so far. Not geographically correct, but something to remember it by. Happy. Also, your body is going to be regulated by that same mechanism, right? You've got a ton of water in your blood plasma that's going to carry the heat with it so that you can regulate your temperature more easily. And speaking of your body, anytime you sweat when you get hot, that sweat is going to carry a lot of heat with it, which means if you're super hot and you start sweating up a storm, then every time that water evaporates, it's bringing heat with it. That's going to cool you off, thermoregulate. We're thinking homeostasis, and life is good. And finally, capillary action. Again, cohesion and adhesion working together to stick both to itself and to the things around it. So if you've got a tiny little tube, water is going to be sucked right up through it because of the fact that the start of water, the first couple of droplets that come up are going to be attracted to the walls of whatever the surface is, and then more water is going to follow behind it. That's going to lead to things like a transpirational pull, which we see in all of our vascular plants. Okay, pretty important stuff. Oh, one more that I forgot to mention. Picture a glass of water here. And with most objects, anytime that they get really, really cold, they're going to increase in density, meaning that the solid version of most things are going to be more dense and sink. However, when we're thinking about water, we know that our ice cubes are floating at the top. This is the most ridiculous ice cube cup of water ever, but there we go. It's floating on top. Why do you care? Well, if you're a lake animal, it's really good to know that your lake is going to have an insulating layer of ice on top of it, and you get to live your little fishy life under in the water without freezing to death, because the entire lake is not going to freeze. That is also responsible for the annual turnover, where you have large amounts of water coming up through the ice once it starts to cool, and we'll talk about that in later sections. So recap, why do we care about the properties of water? Well, all of this starts with cohesion and adhesion. The fact that cohesion, or that water sticks to itself and sticks to other molecules, is going to lead to the fact that it's a universal solvent. That way we can have different items or different molecules dissolved in our blood. That cohesion and adhesion is going to lead to the high specific heat and high heat of vaporization, and to capillary action, and to the density of ice. And to what do we owe this pleasure? Of course, hydrogen bonding, because of the fact that water is polar. Yay!